Hello everyone, I'm sorry there was some internet issues, so I got disconnected. I'm back now. Good evening, everybody. Good evening, everyone. Good evening, Jasmine. I was expecting you. What about others? Can we have some quick hellos around? All right. So, good evening, Priyadarshini. All right. So, as you people were waiting for some question discussion from pedigree analysis, so we'll do it today. Okay. And as you know the drill, at the end of the session, there will be some freebies for you that will help you in preparing for your CSIR exam, as well as there will be the Zoom class link where you can. Hello. Hello. Hello, everyone. I'm so sorry. Today there is this internet issue we are facing. Can you people hear me now? Is the voice clear, everybody? All right, excellent. So we will start now. I'm so sorry for this delay and thank you for being patient and be there. Okay. So so here the question is talking about, so here the pedigree chart is given and you have to understand, or you have to study the pedigree chart, and then you have to decide what is the mode of inheritance that is happening here. Okay, so the mode of inheritance. Okay, so first thing is that you should know what are the signs and symbols in pedigree chart. So in the pedigree chart, whenever we use square, means it is male, circle is for female. Okay, now if there is mating between male and female, then there will be this horizontal lines, and their offsprings, which are who are the results of the mating, will be shown from the horizontal line. Okay, so here, as you can see, and this dark ones, okay, the solid squares or solid circles, means these are the one who are affected with that particular trait. Okay, and there is this sign here, that means this person is dead, it is like she is deceased. Okay, now you have to see what is the mode of inheritance. Now let's check the option. So there can be 6 different mode of inheritance, but there is no need of analyzing each of those mode of inheritance. Okay, you can just select those mode of inheritance which are in the option, because only one out of the 4 will be the answer, right? So in the option, if you see, there is autosomal recessive, autosomal dominant, and X-linked recessive. Okay, so basically here you have to check for 3: autosomal recessive, autosomal dominant, and X-linked recessive. Okay, now let's check for autosomal dominant. What is the feature of autosomal dominant? That every affected individual will have at least one affected parent. Okay, but this is not true in this situation, because these 2 individuals are affected, but none of its parents are affected. Okay, so autosomal dominant, not possible. How about X-linked recessive? Now X-linked alleles, they will show a they will show the inheritance, they will show a particular inheritance pattern. What is that inheritance pattern? That we call as the crisscross pattern of inheritance, right? So the males will get their X chromosome only from their mother. Okay, now here, yes, it is possible that the male here is affected. Okay, and it is possible that it is X-linked recessive, because the mother is having the might have been heterozygous. Okay, but that situation does not hold true in this case, in this scenario. Okay, where the mother is affected. So if mother is affected, and if it is X-linked, means mother is homozygous recessive. Okay, let's say that this is the affected allele, small x, and mother is homozygous recessive. The son will receive his X chromosome for sure from mother, and the other will be the Y chromosome. Correct? Now, in this scenario, if you see, so the son here has to be affected. And that is also one of the criteria of X-linked recessive, that affected female will have all sons affected. Okay, but since that is not followed here, that means it cannot be X-linked recessive. We can also eliminate X-linked recessive. Okay, so what are we left with? Autosomal recessive. So it has to be autosomal recessive. Now if you see this scenario, this confirms that it is autosomal recessive. Why? Because none of the parents are affected, but the offsprings are affected. So that is only possible if the trait is autosomal recessive. So both the parents basically are heterozygous for the causative recessive allele, and that's why they have 1/4 chance of producing offspring with the homozygous recessive character. Okay, so autosomal recessive, fine. Now who are conclusively telling you that it is autosomal recessive? That you are getting the idea from 3, 2 and 3, 3. So third generation 2 and 3, and fourth generation 1 and 2. So answer will be option A. Okay, I hope all of you understood this, and if you did not, please mark it down and we can discuss during the Zoom class. Okay, now before moving ahead, a quick update on Shaurya batch. So, Shaurya batch, we have moved the timing because admissions are still going on, and the Shaurya batch will start from 2nd of March. Do not forget this date. For sure, Shaurya batch is going to start from 2nd of March. So, if anybody wants to get the admission for the Shaurya batch, which will prepare you for CSIR NET 2023 from Biotechnica, you can get the admission done. Okay, the toll free numbers are mentioned here, and you can also apply for Shaurya batch scholarship. So please give us a call in this toll free number, and our executives will support you and will help you with the Shaurya batch scholarship. All right, yes, moving ahead to the next question. Now, given below is a pedigree indicating a pattern of inheritance. The following statements are drawn from the above pedigree towards the understanding of the pattern of inheritance. Okay, so what are the statements given? First, an affected male does not appear to pass the trait to his sons. An affected male appears to pass the allele to a daughter who is unaffected. All affected individuals have at least one affected parent. The given trait appears to be a recessive one. The given trait appears to be an autosomal recessive one. Select the option for the following from the following that has all correct statements. Okay, so you have to select the all correct statements. All right. Now, once we are clear with it, let's go and check out the chart. Now, in this chart, again, usual square and circle is there, and also there is a new sign where there's a square with a circle with dot. Okay, so a circle with dot or a square with dot will mean that the individual is heterozygous. Okay, or it will mean that the individual is a carrier. Okay, so carrier can happen in which case? Carrier can, so this is a circle with a dot means this is a carrier female. Okay, and when a female carrier, when the causative allele is a recessive allele. Okay, so who is basically a carrier? Carrier is somebody who has the causative allele but do not show the expression of it. Okay, so what do we see here? So let's check each of these statements one by one. So an affected male does not appear to pass the trait to his sons. Okay, now let's check it out. So yes, this male is affected, but none of his sons are affected. This male is affected, none of the sons are affected. Okay, so this statement seems true. B statement says that an affected male appears to pass the allele to a daughter who is unaffected. Okay, now you see here, this male is affected and he is passing it to daughter, and daughter is carrier. So carriers, they have the allele, but it is not affected. So this first statement is correct. Next statement is saying that the carrier is there. Okay, so when we see this male here is affected, but this individual is a carrier. Okay, so the affected male is passing the allele to the daughters, but daughters are not affected because carriers, they do not show the symptoms. Okay, so they are unaffected. Here also male is affected, both of his daughters are unaffected, but they are carriers. Okay, so again statement B is correct. C says that all affected individuals have at least one affected parent. So all affected individual having one affected parent, do we have like this? No. Here the individual is affected, but none of the parents are affected. Again, individual affected, none of parents affected. Similarly, again in the same case. Okay, so this statement is wrong. Fourth statement, the given trait appears to be a recessive one. True, because carrier can exist only in case of recessives. Okay, now E says that the trait appears to be an autosomal recessive. Okay, so recessive and another one is saying autosomal recessive. तो अगर ऐसा सिचुएशन हो ना कि जो दो सिमिलर टाइप के ऑप्शंस दिए हुए हैं, दो सिमिलर टाइप के स्टेटमेंट्स दिए हुए हैं, तो आपको वही स्टेटमेंट सिलेक्ट करना है जो कि मोस्ट अप्रोप्रिएट हो. ओके, विच इज स्पेसिफिक टू इट.
All right. So let's see if can it be autosomal recessive. Now see here, you will see that if the mother is carrier, the the son is getting affected, and when the son is affected, it is never passing to the father is affected, it is never passing to the son. Okay, so it is never passing from the father to son. Okay, which can be a characteristic of X-linked alleles or X-linked genes, right? And it is always passing from affected father to the daughters. Okay, and daughters are becoming carrier, which can be again be true for X-linked recessive traits. Okay, so it is recessive and it might be X-linked. It may not be autosomal. It will not be autosomal because as far as the pedigree chart is given, we don't see any passage from father to sons, and it is always passed from father to daughter, which means that it is a recessive trait. So statement D is correct, but E is not. Okay, so answer will be option 2. All right. See, other thing that you can do is that A, B is for sure, correct. And for sure, that C is incorrect. Okay. So there are only two options with A, B, option number 2 and option number 4. But option number 4 has C also in it. Okay. Which that it is incorrect. So definitely this cannot be the answer. So the remaining option remains 2. Okay. So this is another way of doing the sequential elimination. Okay, and if you do it properly after analyzing the question, you will get the correct answer as well. Okay, तो मुझे लगता है कि सबको समझ में आ रहा है, और आप अपना डाउट भी लिख लो साथ में, so that in the Zoom class we can discuss that. Okay, now moving on to another question, and this question is talking about the pedigree and probability. Now ये वाला क्वेश्चन बहुतों के लिए टफ होता है, लाइक बहुत स्टूडेंट्स बोलते हैं कि मैम ये समझ में नहीं आता कि करना कैसे है. तो let's take it here. So in the following pedigree, individuals with shaded circle and shaded square show the presence of a recessive autosomal trait. The calculated risk of occurrence of this trait for 3-1 is. So 3-1 कौन है? ये यहाँ पे जो question mark डाला हुआ है, ठीक है? So first of all, we have to find. So it is already given that the trait is recessively autosomal trait. Okay, it's autosomal recessive. Now हमको calculate करना है इसका probability. Namaste Amit, welcome to the class. Okay, that's okay. So just pay attention because now we are going to discuss the pedigree combined with probability, those kind of questions. Yeah, good evening, Srividya. All right. So what do we have here? Okay, so this is autosomal recessive. So अगर यहाँ पे 2-1 affected है, okay, so what does it tell us about the genotype of 1-1 and 1-2? So if 2-1 is affected means, for let's say that this gene is A. Okay, so if anybody who is homozygous recessive, they will be affected. Anybody who is homozygous dominant or heterozygote, they will be unaffected. All right. So if this individual is affected, means his genotype is small a, small a. Okay. That means both of his parents have to be heterozygote. So I found out the genotype. Now this 2-3 is again affected, means he is also homozygous recessive. Okay. Now 2-4 is also affected, means again she is homozygous recessive. But what will be the genotype of 2-3? Okay, what is the genotype of 2-3? Okay, now see, if we want the recessive this particular trait to pass on to the third generation, then it is only possible if this individual is heterozygous. Okay, so it is possible when this individual is heterozygous. But what is the probability of that? So that we have to calculate. Okay, see, for this first thing is when both the parents are heterozygous. So they can produce affected individual or unaffected individual. Affected individual you will know immediately because they will be homozygous recessive. Okay. The unaffected individuals who are there, they can be either homozygous dominant or heterozygous. Okay. So among the unaffected individual, how much is the probability that it is heterozygous? So for that, we have to make the monohybrid cross, the very regular monohybrid cross. So here it is homozygous dominant, here heterozygous, here heterozygous, here homozygous recessive. Okay. Now this homozygous recessive, we can cancel it out because it is already affected. Okay. But this much part is not affected. Okay. So if you see the not affected progeny, out of that, what proportion of that non-affected progeny is homozygous dominant? So that probability of homozygous dominant is 1/3, 1/3. Okay. And probability of heterozygote is 2/3. Okay. From the unaffected progeny. Now here from the unaffected progeny, again it is present. So in that unaffected progeny, we need the proportion of heterozygote. Okay. So what is the chance that 2/3 is heterozygote? That will be equal to 2/3. Okay. Now, what are the events required for 3/1 to be homozygous recessive? Okay. So for that, we need 2/3, that is the father, to be heterozygote. We need 2/4, whose genotype is already given as homozygous recessive. And also, we need that the cross between the heterozygote and homozygous recessive produces homozygous recessive. Okay. Now, if we calculate the probability of this, so probability of 3/1 to be homozygous recessive will be equal to, just move the equal to little bit here. So it will be equal to probability that 2/3 is heterozygote multiplied with probability that 2/4 is homozygous recessive multiplied with probability that crossing of a heterozygote and homozygous recessive will produce homozygous recessive. Okay. So what is the probability of this first value? We have already estimated it as 2/3. What is the probability that the mother is homozygous recessive? We already know mother is affected. So we know for sure that mother is affected. So for any event which we know for sure has happened, what will be the probability of it? Will be equal to 1. Right? So the probability that the mother is homozygous recessive is 1. So what is the probability? So last value, the cross here will produce homozygous recessive. Okay, that is equal to 1/2. So again, you can make a Punnett square here for this monohybrid cross and check. So 2 gets cancelled, so it will be 1/3. So probability that 3/1 is affected is 1/3. Okay, so this is just an example. You can take up more questions from that, and you will have to or you can practice and find out the probability. तो इसमें सिर्फ ये चीज देखनी है कि अगर हमको पेडिग्री चार्ट से पता चल जा रहा है फॉर श्योर कि जीनोटाइप क्या होगा, तो फिर उसकी प्रोबेबिलिटी 1 हो जाएगी. ओके. और अगर 2 heterozygotes are meeting and then they have a normal progeny, that the chance of it to be homozygous dominant in case of autosomal recessive trait, so chance of the progeny to be homozygous dominant will be 1/3 and chance of the progeny to be heterozygote will be 2/3. ठीक है. तो अगर ये दोनों चीजें आप याद रखोगे ना, ये 2-3 चीजें, तो फिर ये पूरा कैलकुलेशन बहुत इजी हो जाएगा. Because anyways it is, we are talking about the multiplication rule only. All right. Now moving on to the next question. Okay. Now this question requires lot of analysis. Okay. इसमें कुछ और कैलकुलेट नहीं करना है, कुछ प्रोबेबिलिटी का कैलकुलेट नहीं करना है, पर सिर्फ एनालाइज करना है. The pedigree given below represents the genotype of 4 different loci for children in generation 3. Okay. So first generation, second generation, third generation. Okay. So here the genotype of the third generation with 4 different loci is given. So these standing lines basically are the chromosomes and the alleles are written here. Okay. So there is the loci for A, B, C and D. Okay. So everywhere you can see that all the loci, so A loci has got 2 alleles, A1, A2. B loci has 2 alleles, B1, B2. C loci has 2 alleles, C1, C2, and D loci has 2 alleles, D1 and D2. Okay, right? Now the question is, which of the given genotype is likely to represent the genotype of individual 2-1? So who is 2-1? This female here. Okay. Now, first of all, once we see the third generation's genotype, can you people tell me that these 4 loci, A, B, C, and D, are they present on autosome or are they present on X chromosome? Quickly, can I have some answers? These 4 loci, are they present on X chromosome or are they present on autosomes? Yes, can anyone answer? Absolutely correct, Priyadarshini. This is present. No, Jasmine. It is this 4 loci are present on X chromosome. How do we know that? Okay, see here that the males 3 and 4, okay, they have only one chromosome, whereas the females 1 and 2 have two chromosomes each. In which type of chromosome does this happen? Does it happen in autosomes? No, autosomes are present in 2 copies in both the gender, males and females both. But only in the X chromosome this situation arises, where the males will have only 1 X chromosome, whereas females will have 2 X chromosome. Okay, so this gives us the idea that the alleles here are X linked. Okay, now if it is X linked, okay, so the males, from where do they get their X chromosome? Males will never receive their X chromosome from their father. They will always receive the Y chromosome. So X chromosome they will always receive from mother, right? So males receive chromosome only from mother. Okay, so this X chromosome that they are getting, so they are getting it from the mother. Okay, so if they are getting it from their mother, so who is their mother? 2-1, right? So that means what? Now, if you combine the alleles, okay, so you don't have to write it in the linked gene format. So you can just write the genotype. All right. So when you write the genotype, so what do you see? So A1 is also coming from mother. A2 is also coming from mother. That means for the locus A, the mother is heterozygous A1, A2. Similarly, for B1 is also from mother, B2 is also from mother. That means for B locus also mother is heterozygous. C locus, same scenario. C1, C2. Now for D, they both have D1, D1. Okay. So it is possible that the mother is homozygous dominant here. Okay. But we are not sure. Okay, it can be 1 or it can be 2, just that 2 is not coming. Okay, but what you know for sure, that A1, A2 is heterozygous, for A, B, and C mother is for sure heterozygous. Okay, now when you check the options, now here the options are going to help you again. Now when you check the options, so you see that option 1 has A2 homozygous, not our finding, so option 1 not possible. Okay, option 2, if you see, here it is saying A1 homozygous, again not our finding, not possible. Option 4, if you see, it is saying A1 homozygous for C and D both, turned out to be heterozygous, not possible. So here you are left with option 3 only, where A1, A2, A1, A, B, C, and D, all 4 are showing heterozygous. Okay, so till C we have already confirmed that it is heterozygous. Let's quickly confirm whether D is also heterozygous or not. Okay, now how do we confirm that? So for that, now you have to look at the females here. Okay, 1 and 2 are females. Now for females, since it is X chromosome, females will get their 1 X chromosome from the mother and 1 X chromosome from the father. Right? Now father will have only 1 X chromosome. So there is no chance of any crossing over happening. Right? So there is no shuffling of alleles possible for the X chromosome from the father. Whatever alleles are present in the X chromosome, as it is, the X chromosome will be passed on to the daughters. Okay, so you compare the daughters and see which chromosome is exactly same. Okay, genotype on which chromosome is exactly same means that is the chromosome they are receiving from their father. Okay, so if you see this, then this one, A2B1 C2D1, A2B1 C2D1. Okay, these two are coming from the father. Okay, that means this other two are coming from where? I'll just mark it with different color, means this other two are coming from mother. Correct? Okay, now if it is coming from mother, what does that tell us? That, see here, it is D2. Okay, that means for D also mother is heterozygous. So we have just confirmed that for D also there it is heterozygous. So the genotype will become A1, B, A2, B1, B2, C1, C2, and D1, D2. So answer is option 3. Okay, so as I told you that it is only the analysis that you have to do. Okay, pretty much similar to the question that we have seen in a linked in the linkage session. Okay, where also there was a pedigree chart given and you have to find out the recombinants and non-recombinants. Okay, so pretty much similar to that this question is. All right, again you have to do the analysis to find it out. So this kind of questions, it might require a little bit of analysis. Okay, but it is not that lengthy also. It does not involve any mathematical calculation also. So there is no need of running away from these questions. These questions can turn into good scoring questions. Okay, if you have got enough practice. And of course, if your understanding of the concept is good. Okay, now moving on to the next question here. So this question is about lot score. Okay, see, nowadays lot of times we see question coming from lot score, which is again a part of pedigree analysis only. So what is this lot score? First, let's see the idea. So lot score is usually used. See, first of all, what is this pedigree analysis used for? So pedigree analysis, we usually do it to find out a molecular marker that is properly linked with a particular phenotypic character. Okay. Now, when we are seeing the inheritance pattern of the marker and the character, phenotypic character. Okay, so that inheritance pattern can arise as a result of independent assortment between them or as a result of linkage between them. Okay, so lot score helps us determine whether the inheritance pattern is because of linkage or is it because of the of the independent assortment. Okay, so for that, to calculate lot score, what we do, so we find out the inherit the the ratio of probability that the inheritance pattern, okay, is because of linkage. Okay, and we find out the ratio of it. Okay, so the probability that the inheritance pattern is because of linkage, and what will be the denominator is the probability that the inheritance pattern is due to independent assortment. Okay, so the ratio of these two probabilities, okay, and log to the base 10 of that ratio is what is called as lot score. Okay, this lot score is represented as Z and it stands for logarithm of odds. Okay, I'll repeat. So this lot score that we get, this lot score help us in seeing whether the inheritance pattern that we are observing between a molecular marker and a particular phenotypic character is linked or they are assorting independently. Okay, so for that, what do we calculate? We calculate the probability. First, we calculate the probability that the inheritance pattern that we are seeing in the pedigree chart is because of linkage between both. Next, we calculate the probability that it is because of independent assortment. Okay, we find a ratio of it and do the log of that, log to the base 10. Okay, so log to the base 10 of this of the ratio of these two probabilities give us the lot score, which we represent as Z. All right, now this lot score, okay, so suppose we get the probability that the inheritance pattern is because of linkage, okay, is 0.1. Okay, and we get the probability that so suppose this value is 0.1 and this value is 0.0001. Okay, now you just substitute here in the formula. Okay, 2, and this is log to the base 10. Okay, so if you clear it, so how it will be? Log to the base 10 of 1000. Okay, or 10 to the power 3. So 3 will come to the front, so it will, the answer will be 3. All right, so when lot score is 3, what does it mean? When lot score is 3, it means that it is 1000 times more probable that the inheritance pattern that we are observing in the pedigree chart is because of linkage and it is not because of independent assortment. Okay, so in lot score, this lot score equal to 3 is a significant number. Okay, so when lot score becomes equal to 3 means we have enough evidence to support linkage. Okay, the lower value that we have is lot score equal to -2. So if the lot score is equal to -2 or below that, okay, then it means that we have enough evidence to support independent assortment. And if lot score becomes in between this -2 and 3, that means we need more data to reach a conclusion. Okay, but anyways, if you see lot score which is positive, okay, that means it is supporting linkage. Or if the lot score is a negative value, means it is more probable that there is independent assortment. Okay, now coming back to the question. So the table here shows the lot score of 3 different pairs of genes studied by assessing if they are linked pairs. So lot score for gene pair 1 is 1, gene pair 2 is 2, gene pair 3 is 3. And again, some conclusions are made and we have to represent the statements which are correct. Okay. So if lot score is 1, what does that mean? That linkage is 10 times more probable, right? That is what it will mean, right? If lot score is 1, when you will get 1? When this value becomes 10 to the power 1, right? So if it becomes 10 to the power 1, means linkage is only 10 times more probable. Okay. If the lot score is 2, means the linkage is 100 times more probable. Probability of linkage. Okay. And if it is 3, means linkage is 1000 times more probable. Okay. A statement says that gene pair 1, the probability of genes being linked is 10 times more likely. This is true. Statement 2 says, B says for gene pair 2, the lot score 2 indicates the probability of gene to be linked is twice more likely. This is wrong. It is not twice more because it is the logarithmic value. So it will be 10 to the power 2. Okay, so 100 times more probable. Statement C is that the genes of pair 1 and 2 can both be considered as linked, while genes pair of 3 exhibit independent assortment. That is also wrong, because if logarithmic value, if this lot score is 3 or more, then it supports a linkage. Okay, so this is for sure linked. So it is wrong. Statement C. Statement D, the gene of pair 3 can be considered as linked. So yes, that is true. So what are the correct answers? Option number 3, that is A and D. Sorry. All right. Okay, so we have some time and let's quickly discuss one last question. Okay. So this is the inheritance pattern of a common trait which shows complete penetrance is shown below. Okay. So based on the above pedigree, fill in the blanks from the options given. So trait is dash. So first you have to find out what is the pattern of inheritance here. And next you have to find out what is the probability that this individual will be affected. Okay. So first of all, we have to find out what is the inheritance pattern of the trait. Okay. So for that, again, take the hint from the options. You don't have to analyze and check for all the 6 inheritance pattern. That will just waste your time. Instead, आप यहाँ पे options देखो. So options में 2 ही inheritance pattern दिया हुआ है, Y linked या फिर autosomal. तो दोनों में से कोई एक ही हो सकता है. तो check for both. Y linked, अगर आप एक झटके में देखोगे तो Y linked लगता है. क्यों? क्योंकि सारे मेल्स ही अफेक्टेड है. पर Y linked के लिए सिर्फ मेल्स अफेक्टेड होना इंपॉर्टेंट नहीं है. Also have to check that whether the trait is passing from father to sons or not. If it is Y linked, it will always pass from father to sons. Even if the father has 100 or 1,000 sons also, every single son will be affected. ओके जबकि यहाँ पे ये हो नहीं रहा है क्योंकि 1 तो अफेक्टेड है बट 2-3 अफेक्टेड नहीं है. दिस पर्सन इज नॉट अफेक्टेड. ही इज अ मेल. ही इज नॉट अफेक्टेड. ही इज स्टिल गेटिंग वाई क्रोमोसोम फ्रॉम हिज फादर. दैट मींस वाई क्रोमोसोम मोड ऑफ इनहेरिटेंस इज नॉट देयर. ओके तो वाई लिंक्ड है ही नहीं. तो सीधे सीधे ये दोनों ऑप्शंस हो गए कैंसिल. बचा क्या? ऑटोसोमल. ओके सो ये हो नहीं सकता है यहाँ पे. सो इट इज ऑटोसोमल. सो ए का आंसर हो गया ऑटोसोमल. Now, the second part, the probability that a child from the marriage of individual 3-1 and 3-2 will show the trait is B, considering that individual 3-1 is a carrier. All right. So in this situation, we have to find out the probability. Okay. So what do we have? It is already mentioned, right? That this person is carrier. So if he is carrier and not showing the not showing the symptoms or not showing the trait phenotypically, means this person is heterozygous, and it can only be possible if the trait is autosomal recessive. Okay, carrier है means causative allele है, phenotype develop नहीं हो रहा है means the causative allele is recessive. Okay, so this individual is heterozygous, is already mentioned. तो बेसिकली हमको ये फाइंड आउट करना है कि इनका जीनोटाइप क्या है. So again, the exact same way that we have seen in the previous question. So this individual is affected. The parents will be heterozygous. Means what is the probability of her to be heterozygous? So it will be 2/3. Exactly in the same way how we have seen in the previous question. Okay, that unaffected individual hai, to 1/3 chance hai to be homozygous dominant, 2/3 chance hai to be heterozygote. Okay, now what is the chance that fourth generation is affected? So again, iske liye humko chahiye 3 independent events. First, 3-1 is heterozygote. Second, 3-2 is heterozygote. Third, their cross produces homozygous recessive. So probability of that will be this probability multiplied with the second event's probability multiplied with the third event's probability. So probability of 3-1 to be heterozygote is 1 because it is mentioned in the question. 2-2, sorry, not 2-3, I'm sorry, it will be 3-2. So 3-2 to be heterozygote will be 2/3, and their crossing to produce homozygous recessive is 1/4. So answer will be 1/6. Okay, so this brings the answer to option number 4. All right. So we will stop the live session here. I request the team to post the Zoom class link here so that you guys can join the Zoom class and we can discuss the further questions. And also, please, yeah, so team has already posted. Yes, the Zoom class link is there, and also the freebies link. Request the team, please put the link for the freebies as well. All right. So, guys, please log into the Zoom class, come with your doubt. I will be waiting there, and we can have some one-on-one discussion and some doubt clearing sessions. Hope to see you all in the Zoom class soon. In 5 minutes, I will start the Zoom class. Please come to the Zoom class. Thank you, everyone, for attending this. Thank you, everyone. Have a good evening.